Okay, so here we are, back, and we're going to go over 17.2, which is entitled Numerical Trigonometry. So make sure you have a blank piece of paper out. Take good notes as we go through this. And this really isn't that much different than what we did in 17.1, other than sometimes we're kind of going the reverse direction, and you'll see what I mean when we get to that. But let's try a couple of these first. I'm going to show you two different ways of doing it. So let's say I wanted you to just find the sine of 37 degrees. So a couple ways you can do it. You can go to your book, go to page 567, and you can look in your table, and you look down the degree measure, look down the column that has the degree, it's labeled R, and 37 degrees. You look over under the sine of the angle, and it's 0.602. Simple as that. Why don't you try the cosine of 82? So again, you could look down in the chart, and when you do that, you'll see under the cosine column, it's 0.139. Now, there's another way you can do this, and that's to go and use a calculator. If your calculator has sine, cosine, and tangent buttons, it may have arcsine, arccosine, and arctangent, which is kind of going the other direction, like if you know what the sine is and you're trying to find the angle. Important that you have your calculator set to degrees. Another way of doing this is in radians, but you'll learn more about that next year. So, what you want to do, for example, in that last problem where we had the, what was it, the sine or the cosine of 82, all you have to do is type in, hit cosine, and it gives you the open parentheses, 82, close parentheses, you hit equals, and you get 0.139. Now let's see if that matched what we got before. Yes, it did! Thank goodness. Okay, so why don't you try the tangent of 41 on your calculator first, and then go and try it on the chart. So to do that, go to your calculator, hit clear, make sure it stays on degrees, it should, and, gosh, I already forgot what I was looking for. Tangent of 41, tangent of 41. So, we go tangent 41, and the parentheses equals 0.869. Okay, let's go to our chart. Let's go to our chart here, and we go tangent 41, find the 41 degrees, go over to the tangent column, and it is 0.869. Same way, same thing. So you can use the chart, you can use a calculator. Well, now we want to find the measure of angle A in example 4. If the sine of angle A is 0.77, okay, so we already know that the ratio of, remember SOHCAHTOA, the opposite over the hypotenuse is 0.77, but we don't know the angle measure. Again, go to your chart, look for the one that's closest to 0.77 under the sine column. So 0.77 looks like, 0.777, excuse me, is 51 degrees. Or, on your calculator, let's make sure we got that, so it's approximately 51 degrees. Go to your calculator. This time, we are going to hit the, we're looking for the sine, so we're going to hit the arcsine, which means we know what the sine is, but we're trying to go back and find the angle. So, 0.777, and parentheses, equals about 51 degrees. So, same answer. Alright, onward. Why don't you try this one? Find, I know this writing's kind of funky, but just to kind of mix things up. Find angle A if the tangent of angle A is 0.424. Okay. Again, you can go to your chart, look under the tangent column on page 567, look for what's closest to 0.424, and you would get approximately 23 degrees. Calculator style, we're going to go, we want a tangent, I believe, so arctan of a 4.424, so we go to 0.424 in parentheses equals almost 23 degrees. Okay, good. challenging stuff here. All right, find the missing sides. So we know we've got a 27-degree angle. We know the hypotenuse is 12. We need to find y, and we need to find x. Okay, how would we do that? Well, if we know that's 27, that tells us what that angle is up there, doesn't it? It's going to be 90 minus 27. So, what we can do, we know that that's going to be a 63-degree angle. But we also know that the sine of 27 is going to equal the opposite from that angle over the hypotenuse. So the sine of 27 equals y over 12. Okay? Well, what's the sine of 27? Oh, well, you can go and calculate that, can't you? You can look on your chart under 27. So you go down to 27. You see that the sine is 0.454, approximately. And now it's just a matter of solving for y. Cross multiply, and you get your answer. Okay? Go ahead and do x. What do you think you're going to do for x? X is here. That's the adjacent side. Adjacent, opposite hypotenuse for this angle. A couple ways you can do it. You could use the 63 and say sine of 63 is equal to the opposite side, x over 12. Now that we know what y is, we could actually use tangents. Let's see what I did. I used cosine, right? Because I have adjacent over hypotenuse. So I didn't even need to know that that was 63, but we do. Go find it, cosine of 27. Why don't you go ahead and finish this one off. And we're back. And hopefully you got about 10.692. How can you check it? It's a right triangle, folks. Pythagorean theorem, if you like. Okay, on to number 7. Find the altitude to segment MV and the altitude, or I'm sorry, the area of the triangle of MPV. Okay. Well, we know that that's a 42 degrees angle, angle M. What we can do is what? What do you think, guys? Pause it and think about it for a second if you need to. Yes. Drop that down. We want to find the altitude. Okay? So, if that's the altitude, how are we going to go about doing this? Well, what would get us the altitude? If we know that that's 42, and the hypotenuse here in this right triangle is 14, this side would be the opposite, so we want to use the sine. So it's going to be the sine of 42 equals x over 14. Use one of the two ways we learned to get the sine of 42. Go ahead and do that. It's 0.669, and you end up getting x is equal to 9.366. Okay, find the area now of MPV, the entire triangle. What formula are you going to use? That's right. 1/2 base times height. We know the base is 20. We know the altitude to that base is 9.366. And we get our answer of 93.66 square units. Alright. And I believe we are to our last problem. Find the missing angles. Ooh. Well, what's BC? If this is a right triangle? That's right, it's a triple, folks. It's a triple. What's BC? BC is going to be 12. Yes, it's 12. Okay, so find the missing angles. Let's see which way I went about this. There's all kinds of ways you can do this. You could actually do this without even figuring out that that was a side length of 12. So I said the sine of angle C is 5 over 13. Opposite over hypotenuse. Get that number. So sine of C is equal to 0.385. Go to your chart or on the calculator. Sine what was it? Gosh. 0.385. That didn't work out right. Oh, I should have done the arc sine. That's why. Arc sine. got about 22.6 degrees. So, let's go back to that. And I rounded to 23. Obviously, if this one is 23, what's angle A going to be? You don't have to do any trigonometry to figure that out. You just have to subtract from 90. Okay, and that does it. So you're going to try some problems tomorrow in class. I hope you enjoyed the video lesson. And thank you again to wonderful Caroline's for all of her magnificent skills on the flip video camera. Thanks, Caroline. We're done.